Good afternoon, everyone. How you doing? Hey there, Radio Dwarf. I am back to streaming at noon again after a little while of doing it at like 12:30 and 1, hopefully, because I actually fixed my sleep schedule just a little bit. You know, I have this tendency to end up nocturnal if I don't force myself back over time. I don't know what it is about my biology, but I basically always... Oh, my audio's really low. Hold on. I basically always end up going to bed at around 4 a.m. if I don't manage to control myself, and then I wake up at around noon. And that's just, like, non-negotiable to my body. Like, I've tried for months to try and wake up earlier, and it just doesn't really work out. Like, no matter what I do, if I don't set myself an alarm or force myself or whatever, then I end up late. And I've been working a job with very flexible hours, which is nice on a human level and not good on a time schedule level. And so it's just had me drifting forward and forward. It got to the point where I was like going in at noon and leaving at 10, which is not the most pleasant thing to do. Hey there, Toffee, how you doing? And so for my own sanity, I do want to like get myself back to a waking up at 9:30-ish schedule. Hey there, Tomorrow, how you doing? Yeah, it's one of those things where, like, it's just something that I have to push at forever and ever and ever, and then it never ends, but, like, I can make myself wake up at the right time if I just, like, you know, do repetition and force myself to use, like, a calendar, or an alarm clock, but, yeah. But yeah, hi, everyone. Last time you saw me, I was a little bit concerned about the overarching performance of my, or of the overarching behavior of the fluid simulation that I was working on. And today I don't have all that much more confidence, as you've seen from the stream title. But I do think that I created something. So I guess to start, the simulation that I actually submitted was pretty much what you saw last stream. The only difference is that I started working on creating a system for allowing water to have volume within a cell. But I never finished it. So it was effectively the exact same thing that you saw in the last stream, which turned out to be fine because, like, the day before that I had to submit it, I got my grades back for a previous project and found out that I didn't even need to submit a project because I got the minimum grade that I needed otherwise, which is good and also frustrating. One of the people in the class that I saw was conspiring that they only gave us the grades back now to basically force us to work on the project anyways during finals season. Because if they gave us the grades back earlier, then we would know earlier that we didn't have to put effort into it. But, oh well, such is university, I suppose. But yeah, I didn't end up writing a big-ass academic paper on it because I hate academia so much. And I didn't end up creating like a super convincing and compelling video, but I did record like a 20-minute, just unscripted demonstration of it, which I was actually pretty proud of because I tried to focus on like speaking very clearly, and like I tried to channel being able to talk during live stream into being able to talk like more presentably as if I was talking on stage, and I feel like it worked out. Hello, we're looking forward to learning some fluid simulation tricks. Does it require compute shaders? No, this is all done on the CPU right now. This is kind of a scuffed simulation. I did it for my class. I was taking a 400 level computer animation course, and I wanted fluid simulation in my voxel engine anyways, so I just started running at it. But since then, I've made some adjustments to the algorithm since I submitted it to try and do more advanced volumetric stuff, and you'll see in a sec that it's not exactly perfect. There's some strange behavior going on, but you can see, like, okay, it does flow down when I summon it. It sometimes leaves, like, oh, I wonder, okay. It's leaving these, like, really low layers of liquid, and I just realized that might be because of, the way that I'm handling, like, minimum volume liquids. But you can see that, like, the liquid's pouring down. It's weirdly biased to going exactly one direction right now, which is not exactly what I want. But it is capable of, like, pooling into a depression and stuff. You can do a really good fluid sim on the CPU. John Lynn runs this on the CPU. Does he have papers for how he did his fluid simulation? Because I remember seeing that a while ago, and it was really good. I'd be interested in doing something similar to that. Extend 8 down, set stone, or wait. Extend 8, or expand? 8 down. Yeah, set stone. So if I, like, place a bunch of liquid here, it's going to pool up and fill up this volume a little bit. The main issue is that there's some weird liquid that, like, gets spawned in that doesn't ever move, and that's, like, a weird issue that I'm trying to figure out right now. But you can see that it effectively pools up. The liquid looks really bad right now because I haven't created a proper render pipeline for it. But it pools up in this body of water and then kind of just like jitters about for the rest of it. He used someone else's implementation IRC. I think he linked them in the description of one of his videos. Okay. I'll definitely take a look at that because I kind of want to have a like fully functional fluid sim. And one of the issues that I'm having with my current implementation is you saw how that water was just kind of going on its own little journey across the field. I haven't been able to figure out how I want to handle residual water left behind, because I can showcase an issue. So I think the very last thing I did was I stopped skipping it if the liquid volume is equal to the minimum amount. Because that was my initial plan for settling liquids, was if it was at its minimum volume, then it would stop flowing and then eventually evaporate. But I realized after creating that, that kind of creates this weird ooze-like behavior. Oh, thank you for the Prime subscription, Trixon. How you doing? So, like, right now I've got the limiter on so it doesn't move if it's got minimum volume, right? If I do something like this... Hold on. Let's... expand 4 this away. Alright. Set liquid, Zeus, default, water. You'll see once it flows that it kind of just leaves like this sludge a little bit. Like it stops moving entirely when it like reaches minimum volume. And it doesn't really work like you would expect water to. Does it even make sense to run physics simulations on the GPU? Shouldn't the GPU just do rendering/particle simulation? I'm not an expert on GPU-driven like simulation and stuff, or compute, but I know that a lot of people do use GPUs for highly parallel operations like fluid simulation. Yeah, like, you can absolutely do very cool simulation stuff for the GPU. There's like a lot of compute stuff that they can do that I feel like most people don't pay attention to. And I'm not saying I'm better than that, because I don't either, because I don't understand how it works, but... But yeah. No, the GPU is definitely a viable option if you want to have a physics simulation. It's just not something that I'm super interested in. My game's heavily CPU parallelized anyways, and I want to continue doing that. I want to go all in on pipelined rendering at some point, and basically use a parallel task executor for actually doing all the operations like lighting and physics and stuff, and then have a render thread that's entirely dedicated to rendering that uses data that is cached from the previous frame except for camera position. So just wondering, are you a master's/PhD student, and do you recommend a master's program with a great graphics programming focus that offers online education? I am a undergraduate student. I'm in 4th year of university, and I don't plan on going on into a master's or PhD. I guess in general though, if you're going to ask if I recommend like studies, like post-secondary, I guess my biggest thought is, what is your motivation for doing it? Like, so for example, I went to university mostly out of circumstance. There was a reason to do so. It was possible for me to do it, and I just went because that was effectively what was expected of me. And as far as education goes, I honestly think I learned very little from it. I don't know if this is like just an issue with my school or if it's like a general education thing. But my study, my program, which was computer science, focused a lot on theory and mathematics, which is not something that I particularly feel I needed to know for the things that I wanted to do. And the things that I did need to know, the internet has resources on. Perhaps in a master's or PhD study you'd get more in depth there, but I found that like I never really got deep enough into the programming side of things to actually feel like I was learning anything. That said, I also did have a basis of knowledge before going to university, which a lot of my peers didn't. And from what I understand, a lot of them got more out of the programming side of the course. I just kind of expected that a university level computer science program would be more about the computer and less about the science, if that makes sense. Am I using OMP? No, I don't know what that is. What is OMP? But yeah, like, if you're going into university for just the purpose of education, make sure you have a good program. That wasn't my goal, but if it was, I would have been quite disappointed. If you're going in for the purpose of, like, networking and getting a paper and, like, being able to get a job easier, then sure. And if you're going in to do research, I don't really know anything about that, but I assume that master's and PhD studies are effectively what that's for. Motivation: I spent 11 years working on the back-end software engineering and I hate it so much. I decided to go do the thing I love, game dev, and I feel a master's program would compensate for my missing experience. I would be hesitant about that, mainly just because I find formal education tends to lag behind by several years. Like, my animation course, which is what I did the fluid simulation for, was written in OpenGL 2 using C++ that looks like it was directly ported from C from 20 years ago. Like, sure, there are some really good courses out there that do teach all of the things that you want to know. I just don't know if that's a university-level thing. I find university is really fixated on theory, and particularly they're not good at handling change in best practices over time. Yeah, OpenGL 2. It was shockingly bad. I wonder if I can show the codebase for it. Probably not. It is like a repeated thing they use every year, and I don't want to get kicked out of my university in the final semester. But no, I literally spent like the first week of that assignment rewriting the entire thing to be less shit. They had, oh my god, okay, they had static variables that were set to macros that they defined on a global level and only used in those static variable declarations. There are macros everywhere. I was like, why aren't they using inline functions? Why aren't they using constexpr? And I think the answer is that they just didn't have those when they made the assignment, and then they never updated it after like 20 years. I mean, even then, there was a comment saying it was derived from some other sample code in 2004, so I don't really know what's going on there, but it was kind of brutal. But yeah, so right now, I'm having a few weird issues with the fluid simulation that, like, I haven't been able to identify. This new one particularly. So if I go... You already saw the fact that the liquid is sometimes not, like, disappearing when it's at full volume, which is weird. But I can also show, if I set this to stone, inset 1, expand, oh shit, expand 1 up, set air. This gives us a little basin to put fluid in. If I put down a bunch of water here, hey there, I guess H? How you doing? Zeus default water. So yeah, like this stuff gets skipped, but then if we also look at the fluid simulation, sometimes it will have sudden pops up to like maximum volume as well. Just waiting to see it happen. I might need a little bit more liquid. Let's get some more water in the simulation. Maybe? Did this suddenly get fixed somehow? Maybe I did fix this last night. Last night was a little bit of a complete... Or I guess it was last morning. I did some like work on the fluid stuff, and then I ended up hitting a bug somewhere, and then I stopped, and I don't really remember where I left off, but it looks like I fixed that bug. But the fact that the water is still just kind of static here is weird. And it's weird because this water is actually present. Like, if I go clear liquid, and then I update the chunk, it is actually gone, but it's... I don't know what's happening. I don't know why it's frozen. Yeah, no problem. I hope that helps. I wish that I was, like, better situated to give you advice on that sort of thing. I'm just not particularly into the academia side of things from the, like, in the first place, so... I have a question. Since when is there a let keyword in C++? Since macros existed and I became unhinged. I have a couple things here. var is auto, let is const auto. These ones don't really get used, but they exist. Then I have a couple other weird macro things that I've been messing around with. Yeah, I slightly messed it up just a little bit. But it's great, it's great. You haven't even seen the most of it. Okay, so... So I have this define v, which is basically just for immediately invoked function expressions. So if I search over here, you'll see this is just wrapping an IIFE and returning the result. But then there's also this match statement. What is this? This is a bunch of macros as well. I got really frustrated. So I did some functional programming in F#. And I was a big fan of how it handles match statements, and they don't have any like fall-throughs and stuff. And I wanted to have something similar to that in C++. And I was like, well, macros can basically do what I want, right? So I created this horrible macro set called match, which takes in a condition here, which is either a numeric integer or a string. It'll actually automatically hash a string if you pass in a string value. And then it takes 2 curly braces, because I couldn't figure out how to deal with the macro syntax otherwise, but that's fine. And then you can use a bunch of case expressions that can take any number of matched parameters, and then return a value from it. And so this is the entire, this is the one macro, and then this IIFE just wraps it all in a function and returns the result, which means I can effectively do, switch expressions. So this is assigned to the result of the switch. It also implicitly wraps every value in curly braces, so it's not required to do something like this to define a variable. It does that on the inside of the macro, which is nice. And it also has a default accept function, where I can go and just accept on error just immediately. It's only slightly horrifying. I really like it, but, you know, some people get really weirded out by how much I fuck with C++ syntax. How does my sim work? It's relatively simple. I guess I've kind of convoluted it recently, but I can show it. So basically, when liquids are enqueued, or sorry, when liquids are manipulated, they get enqueued into a list of liquids that need to be updated. Technically, it's a map of sets where the map is the Y level, and then the sets are the X and Z, but that's mainly just for ordering. And then when we process the liquids, we take all of those liquids, and then for each of them, which is just this whole inner block here, we go, okay, is there space below it where the liquid can flow, and how much can flow there? And then if it can flow any, then it adds into it and then reduces the volume by the amount that it flowed down. And then if there is still more volume left, as in it couldn't all go downwards, then it checks every adjacent direction to find if there is a liquid that can accept our liquid there. So either it's empty, or it's got the same liquid type, but it's low enough that it can contain more liquid. Then we sort it so that we find the highest nodes last. So if we end up with, so if we find a bunch of different water values, and some of them are higher than the others, then the water values at the end are the highest. And then we effectively go through each of the directions that it could move, find the theoretical level that the water in all of the positions and the current position would be at if they were perfectly level. So say if I had, for example, a block of water here and 4 empty spaces here, then the theoretical level would be 1/5 the height for each of these 5 blocks, right? And then it does that and then removes the highest liquid value if that level is higher than the current one. So it says, okay, this one's too high, so we're going to remove it from the list that could be propagated. Now there's only 4 that it has to divide the initial value for, so now it's only 1/4. If this one's too high, it removes it 2. Now it's only 1/3. If this one's too high, it removes it 2. And then so we end up with a certain number that can be leveled into. And then from there, we basically go through the list and try to evenly distribute it between all of those cells. And that's what kind of creates the weird sludgy effect, which I'm not super happy with. If I... Whoa, okay. Performance weird there. Hold on. Expand 5. If I place a bunch of water... ignoring the fact that for some reason it's getting stuck in midair, which is a different issue, you can see that this kind of causes it to leave behind little bits of water on surfaces, because once it levels out and gets to minimum volume, it can't split anymore. And I don't really know how to handle that other than maybe creating some sort of velocity field. I'm behind on chat. Hold on. Oh, I actually came from F Sharp a couple years ago, and then I went to Rust before it became popular. I wanted something like F Sharp, but something I can use for FFI. I really like C++ too. I really like C++ and Rust. I don't love F Sharp. I used it for work, and there's some stuff that I think is very cool about it. Like, don't get me wrong. I've integrated a lot of the things that I like about it into different languages, but I don't like the language itself. It's so clunky, and it just makes so many annoying decisions. Oh shit, thanks for the Prime subscription, Brian. Oh shit, ears. Oh no, 2 hours of ears. I always get frustrated when a language doesn't have match expressions because I'm so used to writing them. Same with some types. Some types are so nice. I sometimes kind of cheat them into existence using std variant in C++, but it's not the same. Like, they work, but they're just so frustrating to use. Alright, let me grab the ears timer. Hold on. Timer. 2 hours. Start. I gotta get my amazing monitor or window green screen going on. Let's see, where is it? That's the ears timer. Here's the window capture. Window capture the timer. I'll need to reset the transform. Cool. Ooh. There we go. Flawless. To speed up testing, you could implement a command history and arrow up-down in the in-game CLI and/or autocomplete with tab or control to search in the history for a command. I would really like to do that, yeah. My terminal is a little bit primitive right now. I haven't been working on it a ton because it's effectively temporary. I have a whole GUI system which is partially working, like a lot of the things in this engine, and I have mockups for a really like advanced terminal/chat window that should be able to have like different tabs and coloring and formatting, and I haven't really done anything with that, but eventually I want to use that, and then I'll have like fancy things like that in my actual terminal. But this one's effectively just like a like stopgap, yeah. Like, it's just something that I have for now so that I can actually do what I need to do. It's not meant to be super fancy. I've been wanting to make a voxel engine, but time, yeah, I feel you. I started this project when I was in high school, and then moved on to doing it during university, which took a lot of time, and now I have a job and university, which is taking up even more time. But I'm workshopping ways where I can actually find myself more time to work on my projects, because it's driving me a little bit insane, and I don't know how people do it. But yeah, so right now, I guess my main thing that I want to identify is why is the fluid simulation sometimes freezing in midair? It's really strange. It shouldn't be doing that. Like, and what's weird about it is that, like, it seems like it only happens in situations where there is a, like, block of liquids. So, like, for example, if I just go here, and I just select this, and then I expand 8, so I've got a vertical column of water, and then I set the liquid to water, you can see it doesn't start freaking out until it goes sideways, right? It went down perfectly until it did that. What graphics API am I using? This is Vulkan. I'm effectively using bleeding edge Vulkan. I think it's 1.2 or something. Because I figure by the time that this engine gets released, it'll already be like stable enough that it can be used for pretty much anything. So I think one of the issues, and this might actually be the only issue, which would be surprising, but who knows, is I actually cancel if the liquid volume is equal to 1 here, even if it could move down. Because, like, moving horizontally should probably stop if the liquid volume is equal to 1, but it shouldn't stop if it can go downwards. So let's try doing that. Oh, and you know what the other issue probably is? We're not updating our liquids. Like, if we continue here, then we're not actually going to be updating the adjacent liquids if we did move down. Or setting the liquids. So I guess what I could do is just go if this is greater than 1, or greater or equal, yeah, greater than 1. So then we're only actually moving horizontally. What the hell? Wait, what is this? What is dot pop continuums? I must have, like, fucked up something. Hold on. Okay, sure. Alright, we'll try going if liquid volume is greater than 1 to limit horizontal movement. Oh god, I'm helping design a Vulkan class at my college. Yeah, that's a lot of work. I hope they have prior graphics programming experience, because it only started making sense to me after several years of OpenGL. I do think Vulkan's an excellent graphics API, but I very much agree with the people that say it's not a beginner's tool. Zeus default water. Okay, so it's definitely dropping down more consistently, but it's still getting stuck like this. And the weird thing for me is that, like, it is stacked correctly. Like, for example, this is full volume, this is full volume. It's kind of hard to see because these are just stupid little line strips right now. But they are, like, standing on top of liquid that eventually reaches the ground. Except for... oh wait, no, this one does have a small amount of volume. It's like they're just not updating when they should. Yeah, well, the only prior experience they have is software rendering. I find that the bigger problem is lack of abstractions and guides you can find online. Hopefully, I mean... my biggest thing is, like, the code boilerplate required. From what I've seen in the university courses that I've been in, it's a lot harder to teach people, like, things that require continuous, like, building on top of something that already works without just giving them base code. Otherwise, they get stuck with something not working properly and then it's screwed, and I don't think it would be very nice to manually debug, like, 60 students' Vulkan renderers. Like, my rendering pipeline is 1,700 lines right now, and I am doing some fairly advanced stuff, like vertex pulling and deferred rendering, but, like, even still, it would probably not be less than 1,000 lines if I got rid of all that and just did, like, the most primitive rendering I could. Do you use game engines? I don't really. I mean, like, the closest thing to an engine I've used in the past several years is React.js. If I go over to, like, for example, my most recent Ludum Dare entry, this is all just HTML and CSS in React. Including the actual gameplay. If I, like, move around here, this is all... this is all React, and that's most of what I've done recently, other than working on my own engine. Yippee! Fun, weird trivia about that sound. That was actually me making that myself and pitching it up, because, that was for the Ludum Dare compo. Or wait, no, I don't even think I did pitch it up. I think I just sped it up. Damn, the ears timer is gone? I never thought it would happen. No, it's here. It's on the left. Yeah, I had to make that sound myself because it was the Ludum Dare compo, and I wasn't allowed to use any pre-made assets. I've actually never used Vulkan directly, only OpenGL. I mostly use an engine together with WebGPU. WebGPU is, like, a really cool spec. I think it's really nice that, like, people are formalizing and creating, like, cross-device wrappers for, or cross-device interfaces for rendering that are more general and can be implemented on more underlying hardware. But it doesn't, from what I understand, it doesn't give you a lot of the really low-level control that I like out of Vulkan. I do find Vulkan to be hard to debug when it goes wrong. I mean, I think, in a sense, all graphics APIs are hard to debug when it goes wrong, other than software rendering, because, you know, obviously you can just use all of your tooling that you want if you're doing software rendering. But, like, I find Vulkan's debugging experience a whole lot better than OpenGL. OpenGL just doesn't tell you if anything's wrong. The reason I swapped to Vulkan for this project, because it was actually using OpenGL for, like, 4 years, was I tried to implement persistently mapped buffers for chunk data, and I didn't know that they had a limit of, like, 256 megabytes unless you had rebar enabled, which is, whatever, technical detail, not relevant for this, but the point was I didn't know it had a limitation. And instead of erroring out and giving me an error code, it just silently said, sure, I'll pretend that I have these buffers be persistently mapped, which effectively, for persistently mapped buffers, the idea is that you can write to them from the CPU as though they're CPU memory, and it gets synced to the GPU automatically. And so when I tried to create like 4 gigabytes of persistently mapped buffers when I couldn't have more than 256 megs, it ended up just making them all on the CPU, and then every render step re-uploading their contents to the GPU entirely. And it basically slowed everything to a crawl. And OpenGL did that because it didn't want to give me an error, it just wanted to make it work. And that basically killed my interest in it after a couple years of just dealing with its bullshit. I wanted a language that was like, or an API that was a lot more declarative and told me when I couldn't do something, and had clearly defined limits that could be queried, and had a lot of the new features be like properly supported as opposed to just being extensions that a lot of graphics cards still don't implement. The other huge factor was that RenderDoc doesn't support any OpenGL extensions. So if I wanted to do anything with like bindless textures or persistently mapped buffers or anything, I basically had to give up ever GPU debugging again, which is not fun. I like being able to figure out when things aren't working without just guessing. Actually, that's a probably some good advice. I don't know if you are aware about like RenderDoc, but it's really nice for GPU debugging. I can show it really quickly. You basically give it a executable that runs like Vulkan or GL, or DirectX even, maybe? I don't know if it does DirectX. And then once it renders, you can press a button to snapshot an individual frame. So for example, I want to grab this frame. Let's zoom out just to make it a little bit more impressive. Yeah, let's grab this frame. Then you take a snapshot, and then I can close the program. And this looks like it's just an image, but it's actually not. It's 200 megabytes of data that encodes every single intermediary step of the GPU going from like nothing onwards. So if I go to color pass 1, you can see that I've got 0 inputs and I've got 4 outputs because I'm doing deferred rendering. Position, normal, albedo, which is color, and then depth. Oh shit, why is my father calling me? Hold on. I'm gonna call him back later. Okay. Oh, is that silencing the audio? Oh, it's only silencing it on my side, okay. So then we can go and look at these indirect commands, which are commands that I'm using to render graphics. And you can see suddenly these buffers are different, right? Let me quickly fix the fact that they're upside down and backwards. So this is one indirect draw command. It draws a shit ton of meshes all at once. But I can even go into it and look at the individual meshes it is drawing, which apparently there's a lot that are drawing off screen. My frustum culling algorithm's kind of fucked. But you can see every single one of these is one more chunk, and you can look at the meshes. I can't look at the input data because I'm doing really cursed stuff that means that my vertices have 0 size. This isn't a bug, this is just that the vertices have no data in them. But this is the output step of each of the vertexes, and then if I grab a chunk that is actually somewhat visible and not in the distance, eventually, where the hell is one? Okay, that kind of works. If I try and get close to it, which again is pretty hard to do mainly just because of the shit that I'm doing, but it's a really powerful tool if you're not doing stupid crap like what this is. Yeah, there's a mesh. So here's one of my meshes, and I can look at the individual vertices here. You can see that it's highlighting them as I go through this list. And you can see like the individual parameters that it outputs. You get the whole mesh, you can see the textures, you can go on to like see future passes where I do like deferred rendering where I'm inputting all of this data, and then I output the shaded buffer, which you can actually see that looks kind of weird. So like this is the buffer before all the shading and stuff, and then this is it afterwards, right? It's deferred rendering. And then I can even see like the all of the UI stuff, which renders on its own buffer, and then it gets composited over top, upside down for some reason. There are some quirks with this system, but like in general, it's super, super useful for being able to figure out why a specific thing isn't working. You can even go so far as to like look at the shader steps. So if I look at the a mesh here that's actually visible, let's look at the mesh viewer, reset my origin here. Sure, that's a mesh. If I go look at the texture viewer, so it's this piece here, this little stone bit, I can go into the shader state by going to the pipeline state here. Then I can look at the vertex shader and I can see the bindings that are applied to it, their exact values at that point. I can see the push constants, which is a Vulkan thing. I guess you know what push constants are if you're... yeah. But you can see the push constants, which are, for other people in this chat, effectively uniforms. And then you can see their byte offset, you can see their type, and you can even read their raw buffer. So if I go over to instances, you can see I've got chunk positions, face offsets, and a padding parameter that isn't used for every single chunk that's rendered from the indirect commands. And you can read all this memory, and it's just automatically pulled out of the system. It's really cool. But yeah, RenderDoc is a lifesaver, in my opinion. Yeah, so let's see, what are we doing here? So we have our flow directions, and what I want to do is make sure that liquid isn't getting stuck in a column like that. So it's not being able to move down, which is normal, because it was in a stack of liquid, the liquid couldn't move down, that is to be expected. But what's weird to me is that it also wasn't moving sideways. And it makes me think that I've messed up something. How do I handle texture sampling? I just use texture arrays and bindless textures. So I've just got, like, a bindless array of 2D texture arrays. I create arrays for each power of 2 size, and then I fit stuff into there and pad it. And then I just sample it with a combination of a layer and a array index. So it's weird that the liquids are stopping their movement. My biggest suspicion with that is that maybe when I actually call set liquid, it's not actually working properly. So let's go over to that implementation. Why is that not working? Go. It cleared my keybind for going to definition. What the hell? I just started RenderDoc on GitHub. Yeah, it's excellent. Wait, all of my keybinds are fucked. Wait, no, what? Hold on. This is slightly terrifying. I care a lot about my keybinds. Why is it fucked? Keyboard shortcuts? Oh, fuck. Okay, I'm dumb. I was still in QWERTY mode from when I was showing off the RenderDoc stuff, so all the keys were wrong. Okay, that terrified me. Oh, okay. I used a Dvorak for my general keyboard layout, so I end up... Yeah, I use Dvorak regularly, and then for programs that don't support key remapping, I have a button on the keyboard that swaps it over to QWERTY. And so I was in QWERTY, so I could do the moving around in that, like, RenderDoc view. And then I forgot about that, and then all my keys were wrong. It was terrifying. I use a really non-standard keyboard. I have, like, what's it called? A ZSA Moonlander. Which I really like. It's really nice for my hands, because I have, like, RSI issues, I guess? I mean, I don't really anymore, but back when I was in, like, high school and I was typing, like, 12 hours a day on a regular-ass keyboard with QWERTY, it was really affecting my hands. But now I'm good. I'm happy. So, yeah. So I'm just kind of wondering, so... when we call set liquid, it calls enqueue liquid. Is there anywhere that doesn't call enqueue liquid that is a liquid functionality? If not is empty enqueue liquid, that's weird. Oh no, that's not weird, because if it sets it to empty, then it shouldn't enqueue anything. But it should still enqueue its neighbors, right? I'm just trying to think, like, so if a liquid is removed from its position... I've never used a keyboard other than QWERTY. I'm afraid I'd get used to it. It's great! So we're not enqueuing liquid when liquid's removed, which isn't implicitly a problem, maybe? No, it is a problem. Hold on, I'm gonna create a new function called enqueueLiquidNeighbors. Because this is something that we kind of need. So I'm gonna go into the dimension, and we already have a function called enqueueLiquid. We're gonna go void enqueueLiquidNeighbors. And we're going to create the function here. I'm gonna move these liquid neighbors into a, like, just global scope, or I guess file scope here. We're just gonna call them liquid neighbors. Okay, and then enqueueLiquidNeighbors is gonna take a position, and it's going to go for let nay of liquid neighbors enqueueLiquid nay. Oh, pos plus nay. Okay. Because that will give it all of the, like, neighboring liquids will be enqueued, and then we already do not do anything with a liquid in process liquids if the liquid doesn't exist. So it's not going to do anything if the liquid is empty. So now when we call... So let's confirm that everywhere where we go set liquid, okay, it calls enqueueLiquid. Add liquid calls enqueueLiquid. Remove liquid calls enqueueLiquid if not empty. We're gonna go if not is empty, then we're going to go enqueueLiquidNeighbors. Shit, hold on. enqueueLiquidNeighbors position. And then in clear liquid, we're going to go enqueueLiquidNeighbors position. I've been having to pause my project because I get addicted to it and get behind on other stuff. Yeah, I'm trying to run several projects at once right now, and that's a real challenge for me. I don't like multitasking. It doesn't work very well for my brain, but I still need to do it. It's so frustrating working a job, and then, like, I hate when I actually get kind of interested in what I'm doing at work, because then it makes me think about it outside of work, and that's not what I'm getting paid to do. I don't want to do that. Looking at this makes me feel like working on my own game, not gonna lie. It's kind of like Starbound. Oh, you play Starbound? I absolutely love Starbound, and I feel like not enough people know about it. So I assume it's like 2D sandboxy spacey then? I'm building a linear complexity single-pass C compiler exclusively targeting the Game Boy. Linear complex... Oh, wow. Okay, that's really cool. Multitasking is just so hard. I feel like I set up my brain to want to do something, and then that's all I want to do for like a week. And then if I try to change tasks, it's so exhausting. Okay, so now that we have enqueueLiquidNeighbors, we should be able to just go into here and just call that on position as well. I do kind of feel like this should exist, maybe? Yeah, we'll probably do that over on this one as well. Or no, I mean, the only reason that I would do that is if I'm worried about the cost of setting into a set. Which, to be honest, I kind of am. So yeah, we'll do the if check. Like, it's a low cost to do that, but like, it's very possible for that to, like, expand out into a high cost if we go, if we end up doing it, like, hundreds of times or thousands of times per frame. Hey there, investigator, how you doing? Yeah, so it being linear complexity means you can stream in the code and stream out the binary. That's really cool. How does that work, though? Like, are you just not doing any compiler optimizations? Okay, so that's gonna make it so that we can enqueue the neighbors. I doubt this alone is gonna fix anything, but it's possible that the fact that the liquid's not getting enqueued when they were removed was the issue. So let's just confirm that really quick, and we'll move on. So let's wait for it to build. Well, I have ears like those, but with white fur. Oh, just wait till you get a look at this. Where are they? They're kind of not on the band right now, but I also have white ones. Yeah. I own too many things like this. Oh, see you later. Yeah, the optimizations are going to be a problem. I'm considering leaving it a single pass for debug, but adding an optimization option that deviates from that rule. What is the benefit of doing like a streaming compiler? Is it just like a technical challenge, or is there like an actual reason why you'd want to be able to stream directly to it? Let's try this now. Set liquid, Zeus default water. Tech challenge, that makes sense. Wait, was that all I needed to do? Oh! Wait, that's it? That was the bug? I just wasn't updating when liquid was removed? Okay, I feel a little bit stupid now, but hey, it works, so there we go. It's just like blobbing now. One thing that I wanted to try doing is, so you see how... I mean, I'm gonna let it finish what it's doing real quick. Yeah, so that's effectively stabilized, because I have this if liquid volume is greater than 1, which is causing it to not do anything if it's at minimum level. And that's all I had to do, literally all programmers. Yeah, it feels like that happens a lot. Like, it feels like, oh, this is definitely not the source of my problems, and then I look into it, then it is, and I'm like, oh, what the fuck, why did I wait so long to do that? So if I don't have that system that prevents it from moving if it's at low volume, and then I set water, then we're going to see some interesting behavior. Where now it's going to flow down, and it's not getting stuck, but it is going to flow in specifically one direction forever. And that's because we scan the directions that a liquid can go in a consistent order, and then it ends up it starts by dividing. So effectively the way it works is it finds all the directions it can move, then it finds an integer ceiling of the even division of the volume it has between that number of positions. So if the volume is 1, and then there's 4 positions it can go, then the integer ceil of 1 over 4 is still 1, right? And so it says, okay, that's how much liquid I want to move to each side. And then for the first step, then it'll go through each of the directions and try to add that much to each side, but it'll stop if it runs out of actual liquid to move, so it doesn't ever like manifest new liquid. But because it checks the neighbors in a consistent order, then as long as it can move this way, it will, because that's the first direction it checks when it's at 1 volume, which means that it just migrates forever. Which is really interesting looking, but also not what I want. Maybe this planet has like a magnetic pull and all of the water has iron in it and it constantly goes east or whatever. Just use alpha Minecraft water system with infinite sources spreading. I had a bug where that was happening initially and it was really cool looking, but yeah, no. Does this support hot reloading? No, not right now, unfortunately. You can do hot reloading stuff with C++ from what I understand, but it's incredibly jank. I'm not super worried about it though, because all of the content in this game is not defined in C++. I guess that's a feature that I haven't really talked about this stream. So the whole point of this game engine is to do all of the computationally expensive work on the C++ side, and then have all of the content be defined using JavaScript. So for example, these liquids, all the fluid simulations obviously in C++ here, but if I go to liquid.ts, you can see that they're actually being defined using JS, or rather TypeScript, using a API that's exposed. This is a very primitive API right now, but there's like a lot more advanced stuff for like nodes, for example. Nodes have models and textures and selections and events. If I go to .bind, there's like a lot of logic that can be run through JavaScript right now, and that will support hot reloading. I can easily just like remove all of the registered content and then reload all the JavaScript files, and that will function. So right now I don't have like hot reloading on the engine side because C++ is a real pain in the ass to do that with, but I can do that eventually once the system is stable and you're actually developing. It's like Tiny Lua from what... Oh, have you looked at Gravity Lang? It's like Tiny Lua from what I've seen. I haven't. The project initially used Lua like years ago, but I ended up removing it and swapping it with JavaScript and WebAssembly because I didn't like how limited Lua's language features were. Like, not having plus equals just really bugs me, like more than it should. And I know a lot of people don't particularly like Lua, and I liked the idea that if I implemented V8, which is Chrome's JavaScript runtime, people could technically compile their stuff from any language into WebAssembly and then be able to like, run their code in the engine in whatever language they wanted, but still sandboxed, which I thought would be really cool. Magnetic water pull is the definition of feature, not a bug. Just I++++++. Every extra plus you add increases the amount it increments. So this increments once, this calls I++ twice. Have you ever seen the goes to 0 operator in C++? Look at this. So for let I equals 10, I goes to 0. Do you like it? I don't know why it's... Oh, this needs to be var, sorry. Yeah, that's the I goes to 0 operator, isn't it nice? WASM for scripting? Hell yeah. No, I love WebAssembly. I think it's genuinely the coolest technology that exists in anything for, like, a very long time. Wait, let in C++? What in the macro hackery? This is just, var is const auto and let is auto. And that's a thing? Okay, so this is me shamelessly plagiarizing a joke that I saw on Twitter. This is technically valid syntax, but it's not an operator. So what's actually happening is we're abusing the fact that you don't need to have a permuter in the third slot of a for loop. You have to have the semicolon, but you don't have to have a permuter. So this semicolon makes it valid. This is effectively an empty, like, I equals I, effectively, right? And then this minus minus arrow is actually I minus minus is greater than 0. So it's doing the decrementing and also checking if it's greater than 0 in one step. Effectively, never use this, but use it to confuse students. Yeah, it's honestly really fucking wild. You can add more minus before it to go faster. Wait, can you minus minus? No, you can't do that. Don't lie to me. You're pretty good at this. I hope I can improve my engine further to be more like this. Thank you. Some of my code is really shit, and I hope that doesn't leave you disenfranchised about it, but, like, I do my best to try and make a maintainable system over time, and I hope that, like, it is cool to people, I guess. Oh my god, have you seen the slides down to... Oh, I don't remember what that is, but it was like, it was like something like this, right? I remember seeing the post forever ago, but I wasn't... Because these are just strings, right? Or like backslash in the C++ compiler, is just a thing that you can have, right, at any point. Yeah, oh god. Relational comparison result on... Oh, whatever. Did you guys know that they finally got rid of trigraphs? I'm so sad about it. So, for those that don't know, C++, since it's a really old language, used to have a lot of analogous symbols for things like curly braces and hashes that might not be on all keyboards. So for example, curly braces used to be able to be represented like this, where that's an opening and that's a closing. So you'd be able to go like, let x equals 5 or whatever, and that would be in its own block, but they removed it in C++ 17, and I'm so sad. But there are still digraphs, so you can still do stuff like this, and this counts as a curly brace to the language, which is fucking wild. This is all of the trigraphs and digraphs, so these ones were removed, sadly. These ones are still alive, including all these weird, like, linguistic ones. Very strange, but whatever. But yeah. They're cool. I think they're neat. Pixelated avatar picture? I don't understand. What? Okay, so let's try something. This is gonna be... So does C++ have a rotate? Wait, we don't need a rotate. I'm not in functional programming land, I swear to god. I've been getting functional programming brainworms over time, and I hate it. It's like every time I look at something, I go, oh, well, I could algorithmically do this with, like, a rotate, but that's not good for performance. So, we have these flow directions, and I want to run a random direction so it doesn't always move in the exact same time position. What is this? Let's see. Wait, what? Staring avatar guy meme template. Oh, I see. Okay, so basically the reason that it's always moving in one direction is because flow directions is filled in consistently with these directions here, right? And that's fine because we sort, right? We end up sorting, which means that if there's any sort of differential in the volume, then it's not going to end up going consistently. But what we need to do is, when it is consistent, when you're at one volume and everywhere around you has equal leveling, we want to end up having it choose a random direction. And the way that we can do that, I think, is instead of iterating over this normally, we'll create a offset, which is going to be a rand mod 4, or I guess we'll go floaters.size. And then we're going to go let I equals 0, I is less than floaters dot size, I plus plus. And then we're going to go let dir, oh, this has to be a var. Let dir is going to be floaters I plus offset mod floaters dot size. I guess technically we don't really care about modding this value because it's going to get modded anyways. But effectively what that should do is it means that we're going to start sampling, we're still going to be sampling all of the flow directions because we're going from 0 to the size, but we're going to start at a random position within it. So this won't have any effect when we're sorting because we're sorting before the, we're rotating before the sort. So if there is actually a difference in the volume, then the sort will be consistent, which is good. But if there's no difference, then sort will basically do nothing, and then it'll preserve this randomized order, which means that it'll move in a random direction. I like using them to make code less readable along with spamming operator overload. You're talking about digraphs? The only reason I know about digraphs is I once saw, in I think my university's Discord for computer science and engineering, someone had syntax like that in their bio with just the, like, label, "This is valid C++." And I stared at it and I was like, I need to understand. How is that valid? And then I ended up looking it up. Alright, let's see if this works. Set liquid, Zeus default, water. Okay, so this should preserve all the flowing behavior, but it should also make it randomize which direction it moves if it has no specific place to go. Looks like it's doing that. So yeah, this is effectively the algorithm I had initially, except now it levels the water better. You can backslash plus new line in the middle of a token, any token, including keywords and identifiers, so long as there's no white space on the next line. Yeah, that's a interesting thing. I don't really like it, but, you know, C++ is C++, I guess. Yeah, so it looks like it's working. My current problem with this system is it effectively never ends, right? But if I end it with, like, if it's at minimum volume it stops, then it's going to be like the slime where it just leaves, like, a little path where it moved, which is also not what we want. But if I don't terminate it ever, then it just kind of flows forever and it's laggy and dumb. Can I actually kill this water? Clear liquid. That didn't work. Am I dumb? Hold on. Expand 10 down, clear liquid. There we go, I killed it. It still looks like it's there, that's just a rendering glitch. It is gone. It's just not updating if it's the only thing in the chunk that changed, which is odd. Alright, so hey there Clementown, how you doing? So now, if we go and test this on like a fixed volume, it should actually like level out really nice. I'm hoping. Let's find out. So if I create that and then I go expand 10 up, expand another 10 up, set stone, inset 1, expand 1 up, set air. Now let's actually create some interesting structures here. Let's create like set stone, and then apologies for the shitty texture alignment. It's kind of stupid. Okay, if we do that, and then we set a bunch of water right here, let's see what happens. It should level out in this basin. Alright. Alright. It's flowing. Okay. It's taking a long time to empty there. I tried to make it so that the lower liquids would compute first to reduce that time, and I think I actually did it backwards, and I think the higher liquids compute first, which does the opposite, and just increases the amount of time it takes to level, so I should fix that. Oh, look at it go, though! Even though it's like a really primitive algorithm, it's so satisfying to see it do stuff like this. I just illustrate water in chat, I see. One more curse fact, 0 C array is equivalent to C array 0? What? Hold on. Int x 4 is equal to 0, 1, 2, 3. Int y is equal to 4x. Oh my god, why? What? Why? Okay, what are we looking at right now? Hold on. So, is it losing liquid? I feel like this is like draining. Is it running out of water somehow? Because I swear I put more water in than this. Am I crazy? Like, this seems like a very small amount of fluid. Also, for the record, I'm pretty sure this is, in fact, empty. It's just this is a new chunk. And so, it's not updating. Or not? Wait, really? This is actually here? Why did it get stuck? Okay. Oh! Oh, there's a hole. Okay. Oh, that's where all the liquid went. Okay, that explains why it's fucked up. Okay. Let's try that again and fill in this hole. Okay, let's try this again. Because you can also do 0 plus CRA to get the element. Oh, wait, because you're taking... Hold on, I'm trying to understand this. So this is just a static number. Hold on, wait. So... I don't follow how that would work. It's pointer magic, but like... This is 3... Then, do the square brackets... Are the square brackets indexing... Oh, no! Okay, so it is a syntax thing, right? Like, I'm understanding this right. It's a syntax thing. It's not, like, just some jank with how pointers already work. Translates to address plus offset. Oh, that's fucked up. Oh, thank you for the hydrate, Brian. Okay. So, it still feels like we've lost water somehow. I don't know what I'm looking at. Hold on. I'm gonna set a ton of water in here. Let's see if it fills up. Okay, that's promising. It does look like it's filling. Like, it's definitely filled up to here. Is it going to stay filled, or is it going to go away? I definitely think this is backwards. Which means I just need to go, and iterate this in reverse. Which is going to be fun, because it's a map. I'm feeling like a dough rising. Yeah, it's a little bit blobby right now, and I do think that's because it's got that backwards issue that I was talking about. We'll see if that fixes it in a second here. But it is leveling over time. I'm gonna leave that running while I see if I can fix this code. So let's go, for var it is going to be liquids.cbegin. Or sorry, not cbegin, rbegin, yeah. It is less than liquids.rend, it plus plus. That should be a reverse iterator. Now we can go let y layer is going to be equal to asterisk it. And that should allow us to do effectively the same thing. Oh, this has to be a... Right. Okay. Do I just need to go not equal to? I think I just need to go not equal. Yeah. I very, very rarely use iterators in C++ because they're gross and range-based for loops are better. But sometimes you need them. IRC, it's ill-advised to do less than end, it should be not equals. Oh, okay, perfect. I'm sorry, I read your message a little bit too late. Can't you just use rbegin and rend? Use a view? I'm not super familiar with like the view semantics in C++. I haven't really used them. This actually fucking works. Hold on. I'm curious what happens if I poke a hole in it now. Oh, that's so cool. It's so cool that that's actually working. It's draining out. I'm waiting to see if it actually drains out like this upper step because it's got like liquid in it, right? You can actually see the like the gradient, how the liquid is moving towards the water or like the hole, just sort of like emergently because it's falling out of there and then filling in. Because the end may not necessarily be after the begin in memory. Yeah, that makes sense. I imagine for like non-reverse iterators that's fine, but it's spilling everywhere, and it's lagging my entire computer. The liquid simulation itself is not slow, it's the rendering that's slow. You can see the task status freaking out on the top right. Or maybe it's not actually showing up on stream because it's flashing too quickly. But it's flashing like mad to me, and that's because it's re-rendering all of the blocks every time a liquid moves, which is not what I want. I just kind of janked it into existence because it worked. So yeah, it did empty out this area, and now it's emptying out the second area. That's so cool. Is the liquid falling down the hill? Kind of. I mean, yes, but it's a little bit stupid looking. Neat. Oh, jeez. Okay. Let's kill it, and then let's try, now that I've done the reverse iterator, maybe that will end up fixing the weird slow falling. It's also possible that it's just slow falling because it's just, like, dumb. Using square with a number is basically dereferencing with an offset. Oh, there we go. That is really cool. I kind of want to start using that, but I feel like that's horrible syntax. Alright, let's try creating, like, a large blob of water. And let's watch it fall. Okay, I think that's working properly. There we go, clear that, just to stop the simulation. I want to check one other thing, though. If I go expand 12 up... Oh, no, that is kind of the opposite. So that is going the wrong way. So it was going the right way before, but that was kind of satisfying. I don't know, maybe I'm crazy. Is it nice to have it, like, spread out like that? Let's try it with a larger amount. I don't know if that's how it should work. Hold on, let's try on a new system. There's more of a C left over. Please don't do that, you'll get smitten by Strustrup himself. I need to learn how to pronounce his name. I feel bad every time I pronounce his name because I'm almost certain that I'm pronouncing it way wrong. Alright, let's try this again. Zeus default water. It's like, it's not even updating the top for some reason, and I'm not sure. Oh, wait, hold on. Maybe this is the right direction, because... Well, how would that work? I don't know why it would not have the water at the top. Because if it goes... That's weird. I don't know what that means. My name is just my initials. You can call me Isaiah. Oh, wow. Are you really delayed on stream? I feel like I mentioned your name and I pronounced it H, like, forever ago. But sure, yeah, I'll call you Isaiah. Alright, let's see. Zeus, default, water. This actually isn't going to spawn anything because it's all in blocks. I guess it's really up to taste which one is better, right? Let me start a new simulation and let's try and do effectively the same thing that we did last time and just see if we prefer that functionality. What theme am I using in VS Code? It is... where is it? No, wait. No! Oh shit, hold on, I fucked it up. Where is it? Is it color scheme? I guess it is. It's AU dark bordered. No, sorry, AU mirage bordered. There we go, I found it. How you type things into the console there reminds me of something my nephew showed me on Roblox. Oh yeah? Let's see. Here, let's go expand 20 up, set stone, insat 1, expand 1 up. This is very derived from World Edit, the Minecraft mod. It's actually called World Edit in my code. I mainly just use it as like developer tooling to be able to quickly manipulate the world for testing. Let's do that. Okay, let's try with the water again, and let's see if it does more or less of what we want. Because ultimately this is like, there's no real right or wrong here. This isn't a physically accurate fluid simulation. It's just what we want to see, right? Axiom is world edited on Supercrack. I've seen some stuff about Axiom. I really want to try it. Alright. Set liquid, Zeus, default, water. Huh. I don't know what to make of it, because it kind of feels like it's doing... It's both doing the opposite of what I want, but also looks really cool. I wonder what would happen if we just increase the flow step a lot. Like, if I go over to the world, and we increase the water tick rate to, like, 4 times faster? I have to recreate this stupid block every time. I should just save and load it as a schematic. What am I doing? I have that capability, I'm pretty sure. I don't remember how it works, but if I go look at it, I can figure that out. Minecraft v2, that's kind of the goal. I'm trying to create a voxel engine that has very few technical limitations. So for example, like one really simple one is the world goes infinitely high and infinitely low. You know, it's cubic chunks. But I'm trying to do it in a way that all of the content is defined using a modding API that's stable and supported. I'm not exactly making it for Minecraft 2.0. I have an actual game that I want to make that I think is fairly unique. But like, I have chronic issues with creating and like overscoping things. So, yeah. Stable modding API? Impossible. You, from how Minecraft acts, you would think, but no, it's not that difficult. It's honestly like really straightforward to create a nice modding API if you just care about things. Like for example, the modding API is currently exported by JavaScript, and all the game content that even I make is going to be in the modding API, right? So I'm incentivized to keep it stable for myself. I plan to do API versioning, so when I create breaking changes, which will hopefully be very rare, it will have a new version code, and then the engine will... I'm aiming to support the old versions for at least a year, so that mods don't get deprecated by, like, inactivity. Alright, let's see if I can remember how to save a schematic. Schematic save... Okay, let's try this. Schematic save water. Okay. Oh, wait, that's not gonna work. Because, to actually do this, I need to copy it, I think. Yeah, copy, schematic save water. Now if I go paste. Cool. What if I... Okay, now if I copy something else, then I paste, it pastes that. Oh no. Oh no. Kill the plague. No, I failed. Shit. expand, outset 30, set air. Come on. I have stupid flowers that endlessly propagate and it lags to shit. I might have just crashed the engine by trying to set a huge area to air, though. Or it'll probably work eventually. Oh, there we go. Yeah. I got it. Alright, yeah, so now if I go schematic load water and then paste. There we go. Okay, now I have the basin. Why not have a command to stop fluid/block update loops? That would make a lot of sense. I should do that. Do you have to find dev flag in your code to separate it from your production code? I use if and def debug, which is automatically set by CMake, I think. Sometimes. Sounds like something Obsidian does when it comes to building new features in their app. I use Obsidian. I've never used their like API though. Do they do like versioning stuff? Having to build the structure every test would piss me off. I should automate that. Well, there we go. Yeah, I assume you sent that a little bit earlier. Yeah, oh yay. Why not have a command to stop? Yeah, ndebug is standardized, yeah. Alright, okay. Let's try setting water now that it's 4 times faster. Oh, that's so weird. And yeah, true to form, it's not causing any more lag than previous because the water propagation step is actually really easy. It's just the rendering that takes a long time. It's annoying how this stuff just kind of sits forever. Something that I've been tempted to try and do is implement like a gradient field / like velocity field. So like when the water is moving, when it's a higher volume, it's more directional because... So the reason that it gets stuck like this is because it's not granular enough. Water is very granular, it has 16 levels of volume per block. And the way it flows, it kind of creates a natural slope, which causes the liquid to fall down very smoothly when there's a lot of it. But when it gets to this point, this is not granular at all. It's either solid or not. There's no sense of gradient that this is down. So it gets stuck just randomly for a very long time, potentially forever. So something I've been considering doing is hijacking the fact that water knows its gradient when it flows, and effectively caching the gradient of liquid in an area, and then for a certain amount of time continuing to apply it when a liquid has no bias to where it goes. So when it gets to really low volume, if it was moving this way up until then it keeps moving that way for a bit longer, and then eventually it kind of like fades away, that gradient field. You could also make water stick to other water. I could try that. I don't know how I would model that though in a node system. But yeah, look at this. It's like, it is perfectly level. Like, it is like jittering a little because there is, like this layer isn't perfectly filled. But it is level as far as like, it goes, like as far as the lower level is going, it's perfectly level. Let's try this again. Zeus default water. Oh, that's so weirdly satisfying to look at. Fucking hell. It's so cool. Ah. I really want to make water transparent. This is not the final rendering though, so I don't want to invest too much time into figuring it out. Because I already tried making it transparent and it didn't work, and that was really confusing to me. But I don't want to debug this stupid shader when it's going to be completely ripped out anyways. I want to do carpet meshing, I think is what it's called, where effectively instead of rendering planes like this, I want to take the volume of each liquid in each block and then kind of create quads that map across them, so it creates like slopes instead of like solid layers that jitter like that. Why does it end up on one side for each step? I think it's just because I'm starting over here, and then so it flows this way. I can try it the other way around, and it should end up over here. Ah, shit. Like, it should end up here because it's flowing that way, because of the way that the gradient works. Maybe. Oh, maybe not. No, it looks like it does get kind of stuck. Interesting. I wonder if it's biased. I actually have a theory about that. Hold on. So, there's two things it could possibly be. One is that technically Rand is not evenly distributed because it's got like an integer max, but that's a really weird niche case that would cause it to be biased. The other is that I'm using sort and not stable sort. And it's quite possible that because I'm doing that, it's like messing with the ordering a bit. I didn't really consider it super important to do stable sort before, but I think it's worth trying. Let's try it. A lot of their features are optional plugins that you can use that uses their own API. Yeah, I have seen that part of Obsidian. It's very cool. Probably some ceiling plus float bias. Oh, you think it's that, huh? I mean, there's no floating point math in here other than just the division for how the water should be distributed. Which shouldn't affect the flow. Let's try it again, though. So if I do that, is it going to go over to the left still? Yes. Huh. Wow. Is it really the rand that's the problem? Like, if I change this over to be I plus offset mod floaters dot size. If I do that, and then we go negative offset plus 4, so this should swap the cardinality of the bias if it's caused by the rand, because now we're taking the offset and using it in reverse. I guess let's find out. Symmetry violated. Oh no. Oh, it could also actually be due to the way that the unordered set works. Because even though it's unordered, it's still being placed in a consistent order, maybe? Oh wait, hold on. What? Oh, schematic load water. There we go, okay. I was using the wrong command. Alright. So is it gonna get stuck to the other side now? No. It really likes this corner. I have no idea why that would be doing that. You should probably add an arrow up key for history stuff. Yeah, someone mentioned that earlier in the stream as well. You know, it wouldn't be that hard to do. I do have file manipulation. Should I do it really quick? Should we try and speedrun it? Alright. Let's go to the world edit command, then to meta HUD. Okay, that's not what I wanted. We want probably command? Is this where it is? Yeah, this is where the GUI indicator is. Key press, backspace. Okay, let's change this to handle keyboard shortcuts. Okay, and we're gonna go if key is equal to key backspace. Then we're gonna do if not command buffer dot length return, then we'll do that in here. Else if key is equal to key up, then we're gonna go, let's start with just like an in-memory history, and then we'll move it to the file. So let's go const history is going to be a string array, and it's gonna start at 0, and whenever you go commit command, no, not commit command, yeah, okay, we're gonna go, history.push, oh, hold on. So command buffer is a string, right? Yes, so we'll go history.push command buffer into here, and then we're gonna go, const history index is going to be equal to a number. We'll start it at -1. I'm just trying to think of how we do this. So we'll start it at 0. Or no, we'll start it at -1. And then history will get pushed into at the beginning. So that's going to be unshift, I think. Pushes it into the beginning. Yep. So we'll unshift into there. And then we're going to go if the key is up, Then we'll go history index is equal to history index plus 1, math.min, history.length minus 1. This needs to not be const. And then we're going to go, command buffer is going to be history index, or history index. And then command indicator.content is equal to command buffer. Then we'll go else if key is equal to key down. Then we're going to subtract, and we're going to min it at 0. Or we'll min it at -1. Then we'll go command buffer is going to be history index is equal to -1 empty string, otherwise that. So it'll clear it if we get to -1. Alright, let's try that. You haven't tested the other side where water moves to the side you place the water. Yeah, that's worth trying. But let's quickly see if this history thing works first. So if I go, set stone, set dirt, set air. Okay, that does not appear to be doing anything. Oh, because I didn't actually build the code. I'm done. Hold on. Build my mod code, please. There we go. No, you're dumb? Set dirt, set stone, set air. Hey, look at that. Cool. Okay, down isn't working, though. Down is always going to... Oh, because this needs to be math.max. Yep. Okay, cool. Now we just need to make it so that it populates from a file. So let's go let's import file system. fs.try_open. Or wait, there's already a read string. We'll do try open. fs.try_open. I don't remember the format of this. It's been so long. Where are my file strings? Okay. I have like a virtual file system thing. So we'll go re world edit command history.txt. And then we're gonna go f.read string dot split new line, and we'll go history is equal to that or an empty array, which means that this realistically should just be up here, this should be up here. Then we're gonna go f.close. Cool. And then whenever we want to append to it, whenever we call commit command here, we want to add to it, so we'll open the file, and then this takes in a thing, right? Dot open, and then create is a boolean, yeah. Have you tried Vim bindings? I haven't. I don't think they'd work for me very well because I use Dvorak. Like, I know there are Dvorak Vim bindings, but I don't want to. I like my stupid regular bindings. Why is this angry? History is certainly not being used. Oh, because I'm creating a local. Okay. Okay, f.write. And we're going to write in history.join by a new line. Then we're going to close. Alright, I think that should do it. If it does, that's actually really useful for not a lot of effort. So where would that go anyways? That would go into... Where are the files here? I'm trying to remember. I think it's just in res. So yeah, if I go set dirt... command history.txt. Okay, set dirt, set grass, set stone. Ooh. Ooh, okay, that's not quite right. I know why. So this is appending the whole history, but it's also not adding a new line after it. What we want to do is just put in command buffer, and then a new line. Okay, let's clear the command history real quick. By the way, fun fact, I met the guy who wrote the press F to pay respects meme. Really? Wow. Okay, set dirt, set stone, set grass. Okay, dirt, stone, grass. Why can't I go up to the top and then run out? That's weird. Oh, I guess because it gets the new line at the end, huh? Let's map it, and then map it into a boolean to trim any empty lines. Alright, let's try now. So, now if I try to load it, I should get... Ooh, okay. I didn't get any of the actual commands when I tried to load the history. Huh. Oh, fuck. This shouldn't be a map, this should be a filter. There we go. Okay, let's try that again. So if I start... Yep. Okay. Oh, wait, I've got the word false in there now. That's fine. So, dirt, stone, grass, false. Although, it is in reverse order? Because it should be, so if we append a new command, set sand, that adds it to the bottom, but we're reading from the top, so we should do dot reverse here when we're loading. Yeah, I'm sorry, I'm a little bit dumb. Alright, okay, so now we should get sand, grass, stone, dirt. If I go set a goblin, cool. Alright. Awesome. So now if I go schematic load water and then paste, if I wanted to do it again, up, up, and then paste. Up. It's getting like... Oh, one other thing I need to do is whenever you actually commit a command, we need to set history index is equal to -1 again to let you be back on a new line. Otherwise, it's going to be broken. Makes a whole ass box luncheon in Vulkan. Yeah, I'm dumb, shaking my head. Look, okay, I can still be dumb while occasionally doing smart things. It's not impossible, and it's very real to my lived experience. Here's a question. So when I do that, now we end up with, like, 2 copies of it, right? Because I don't want these new lines in here. Hold on. Let's actually change it so that if command buffer.trim is not equal to an empty string. Okay, okay, so right now, if I commit a command, then it will put the same command back in there, right? So, like, okay, you may have a little dumb as a treat. Congrats, you made your life easier. Yeah, this does improve stuff. I'm just kind of curious, though. So let me quickly remove the repetition here, just so that we can demonstrate what I think is potentially weird. So, if I do this, and I go up, up to get schematic load water, and I press enter, there shouldn't be a new line there. Stop existing. Oh, it's because... Yeah, and then I go up, up to paste. Now our history entry is like this, right? Is that okay? I think that's fine. I love the pre-render jank of the window manager just taking whatever was behind the window as the contents. It's so weird. I've had, like, it do that from different monitors and stuff, too, and, like, leak what's on my other screens, which is just currently my face and chat, and then C++ reference. But, like, yeah, it's strange. So I don't have a built-in command to flip this, which is annoying, but I can just do that myself. Let's do that, set stone, that, press up. Oh, look at that. That is really nice. And then let's grab the corner, the other corner, set air. Let's actually save this as, like, water 2. May as well keep it around, right? Yeah, copy, schematic, save, water 2. Okay, now let's try. So that's not enough liquid. Linux jank, my beloved. Doesn't Windows do that too sometimes? I agree, I hate Windows, but like, yeah. It does seem like it likes that corner still, I think. Yeah, it definitely likes that corner. I don't know why it feels that way. Water everywhere! So much water. Oh, I'm so, like, happy with what Valve's been doing with getting, like, Proton, like, stable and actually making Linux gaming a reality. It's really cool, and I'm always worried that because they're just a corporation that they're gonna end up doing something really stupid, but I'm not gonna not praise them for what they're doing right now, because it's genuinely really good. I have a pool of water! It looks like garbage, but, you know, let's try putting, like, expand -10? That did not do what I wanted. Hold on. Expand -10. Yeah, there we go. Flood! So, the other thing... Look at my stupid command. I fear the day Gabe leaves us. Yeah, Valve's gonna be fucking weird when he's gone. Okay. So let's try something else. So, currently we're doing things backwards, right? Let's try going forwards, and we'll see what happens. So if I load up... could you have a larger radius examined for water distribution instead of a block radius? Then water could possibly flow in the direction where the vertical level is lower instead of flowing randomly. I have considered doing that, but, like, ultimately it doesn't really work because, like... I mean, it does increase, or it decreases the, like, chance of it not working, I guess, is probably the right way to say it. But, like, it's still going to be weird, right? I'm gonna make it so that if I am typing and then I commit from the history, it doesn't actually push a new command. Like, it's not gonna push to the history if you just pasted from history. But if you press any key, else if history index is not equal to -1, history index is equal to -1. So that should make it so that if we type anything, then it resets, I think. So if I go back to command history, let's clear out all these duplicate items, just so it's easier to actually see. I moderate Sony Santa Monica's Discord, and when I was in San Fran, which wasn't far from LA, all things considered, I asked them if I could drop by expecting them to decline, and they agreed. Oh, that's really cool. I was in San Francisco recently. No, sorry, not San Francisco. I always get them mixed up. I'm Canadian. I'm allowed to be bad at American things. I was in Seattle, but I am planning on going to San Fran, I think, because that's where GDC is, right? I will be attending GDC this year, which is exciting. So if I go up and I select the schematic, that doesn't create a new history entry. But then if I go up to paste, it still shouldn't. Good. But now if I go up to set liquid and then I go wine, that created a new history entry? No. What did I fuck up? So handle keyboard shortcuts should... yes, GDC is in San Fran. I know more American things than I'm happy to admit. I'm European. I'm just really bad at geography in general. That's a decision between performance and more flowing weirdness. Yeah, that's true. I'm hoping the liquid velocity fields thing that I want to do fixes it. I wonder why this isn't working. So let's console.warn resetting history index. And let's confirm that it's actually building, because sometimes I find the build tools get stuck. Eric was so nice. Is that like, I assume that's a Sony person. Okay, if I type, yeah, so that is resetting the history index. So then, at this point, if history index is not, oh, this should be equal to. There we go. Oh, there we go. Sorry, I missed that one. Not only did they agree, the game director of God of War Ragnarok offered to get lunch. Spent 2 hours one-to-one. That's so cool. That is super cool. Sorry, I specifically missed that message. Oh shit, that's not working. Why are you not working? What is wrong with my code? If history index is equal to -1, then we write the command. I don't understand why that would not work. Hold on. I went to go visit my friend who at the time lived in San Fran. That's cool. Okay, let's confirm here. So if I write a command, committing -1, committing -1, is it because I'm pressing enter and then it's resetting it? I swear to God. And that's probably exactly what it is. Yep, that's exactly what was happening. Okay, hold on. Let me quickly remove the debug code, fix the history, and then we should confirm that that works. So I'll clear out all of the duplicates. I like how you can see that I was trying to get a wand here. Oh, wow. Wait a sec, is this game made in TypeScript? The native code that actually runs the rendering and the computation is all in C++. But I have a stable modding API that uses V8, which is Chrome's JavaScript runtime, to add all of the game content and logic. So the stuff that you're seeing me edit in TypeScript is mod code, which defines pretty much everything you see, and then the C++ stuff is for actually simulating and rendering. So if I go expand -10, that does not include, or that does not add to the history, good. But if I do expand -100, it does get added. And if I go schematic load water, and then paste. Okay, paste gets added, but schematic load doesn't. Is that actually behavior I want? Because now I have to go all the way up to get the schematic load again. I might be crazy, but for now, we're gonna leave it as is. Alright, now let's go set liquid, Zeus, default, water. So this is the same behavior that we saw before. Perfect. Now that we're done fiddling with command stuff, I'm sorry, I'm gonna fiddle one more time. I'm adding back the always propagating. I'm sorry. Okay, now that we're done fiddling with command stuff, let's try swapping... Oh wait, no, this isn't the reverse code anymore. I changed it, right? I'm so frazzled today. Yeah, so we are going forwards. So let's take a look at this water mechanics. So it's either that, which is kind of a slow, consistent flow, or we go in reverse. And if we go in reverse, we should see it do a few different things. So let's go schematic load water. Wait for the world to exist, please. Yes, paste. Come on. Yep. Alright, now if we do it here, this is the other potential direction that we could flow it. which is very similar but different in some weird way that I feel like I can't exactly describe. Like, it's more outwardsy. Like, it's not just going down, it kind of like spreads out. Does that make sense? Like, it feels like it's a more clean flow. Let me actually clear that liquid. Stop it. Okay. What if I start some at the top of this mountain? Oh, thank you for the hydrate. I'm choking on my own water. Control R for history search. I don't think I need that quite yet. Those 3 days were wild. I even very briefly met the CEO of Discord. Wild, that's really cool. Okay, let's create a waterfall. I feel like that looks really good. And really slow. Oh no. Oh no. No! My physics broke. Oh, shit. Okay. I might have gotten a little bit too crazy. Hold on. TP 0, 100, 0. No, all the liquid got deleted, I think. Yeah, I think it got wiped because I went too far away. Let's try that again without me being dumb once the task status cleans up its mess. I got flung all the way over there. Alrighty, Puckaroo, it's nearing 11 PM. I'm gonna go sleepy. See you later. Thank you for hanging out. This was fun. Alright, let's try this again. Even though it's still simulating something. What is it still simulating? Oh, there's a few little dribbles of water down there. Oh, they're all migrating. Hold on. Ah! It might be better to just restart the game. This clear liquid command is gonna take fucking forever to propagate. It's gotta find every liquid in every block, and I do not have bulk operations yet. So it's just calling a JavaScript API call for every single block in this range. Yeah, maybe I should cut my losses on this one. Hold on. Die. Okay, let's try that again. I really want to see what that waterfall looks like. Here we go. I have no idea why it's crunching performance so bad right now. It's weird that it's doing that. It's actually making me wonder if it's the simulation that's lagging, but like, that isn't consistent with what I've been seeing. Huh. Very strange. I should probably kill it. Water naturally tries to fill the space it's within, so having it flow outwards as well as down makes a lot of sense. Yeah, agreed. I think it makes it a little bit less predictable as well. Like, if you have a vertical column of water, it doesn't just move down in a perfect vertical column, it, like, spreads out. And I think that's nice. Let me teleport to, over here. There's, like, a bit of a, like, depression in the ground over here that I can try filling up with water. I'm gonna segment it a little. I'm gonna put some stone here, and some stone here, and I'm gonna go... that's a bit too much. Expand 40 down, expand 50 down, walls, stone. So let's just try and fill up this region with water from here. So let's go... Set liquid, Zeus, default, water. Wow, it's still crunching. Okay. This might actually be the simulation that's crunching. How do you mesh the water currently? Is it per chunk? Yeah, the water is meshed per chunk. I swear this wasn't happening before. Huh. It's definitely, like, new. Oh, okay. Yeah, I kind of do think it is the simulation being slow, which is kind of understandable. The code is very unoptimized, but currently, yeah, it gets meshed. Oh no, it probably is the meshing. I'm guessing it's the meshing. It gets meshed per chunk, but it also remeshes all the chunk blocks, which is not good. I did reverse something, but that shouldn't do it. My main thought is actually, so it used to only update once every 4 frames when it was running at full frame rate. And now it's running every frame, and I think that the stutters are now just like horrible lag spikes because it's happening every single frame is the actual issue. Maybe. Either way, though, all of this will be improved when I do the proper rendering that I actually want to do, so... Yeah, no, it's really, really unoptimized. The reason that I've been leaving it like this is because I want to do an entirely different shader. I'm actually considering using mesh shaders for it. I want to send the volume of all of the water nodes into the GPU, and then I want to basically just create a carpet mesh for the top layer of it, as opposed to all of the individual non-called faces down there. And I think that'll overall be a lot more performant in all directions. I really want to just poke a hole in this now and see all the liquid spill out. It's so weirdly satisfying to just see, like, a lot of it just spread out over a large area. Or, like, what if I create a big hole? It'll eventually get there. Yeah. Yeah, I really like how this is going. So I guess what's next for the project? I probably want to end up, like, doing the remeshing stuff sooner rather than later, so it doesn't end up continuing to do this. I'd like to take a hint from the physics simulation book and try to multi-thread this based on intersection. So, like, for example, in physics simulations, they end up identifying the things that are likely to intersect, and then dividing any groups of work that are not going to intersect into different threads, and then do the thread operations and then return everything. I was thinking about doing that with my system right now, because I have a kind of shitty mutex system for acquiring chunks. Like, chunks have a shared lock attached to them, and I really don't like using mutexes when I can avoid it. They slow down the fast path a lot just for the sake of doing multi-threading. And while multi-threading is super powerful, it makes me think surely there's a better way to do it that doesn't require a mutex all the time. I've been considering trying to do some copy-on-write shenanigans with chunks, specifically when they're used in multiple threads. Like, I could use an atomic boolean, perhaps, for flagging that it's used in multiple threads, and then do copy-on-write if that's the case. Look into Harris lock-free lists. Ah, non-blocking linked list, okay. Yeah, I'll look into that as well. What I'm mostly worried about is, like, the chunks block data. So, like, for example, if I'm doing a liquid simulation on one thread, and then the blocks get changed on the other thread, I don't care if the liquid simulation is non-deterministic and, like, assumes the block is still there, but I don't want a memory corruption, and that is, the main concern, right? So, like, it doesn't matter if the thread knows the block is gone, doesn't know the block is gone, but I need it to think that there is a valid block of some type at that position. And so I'm like, thinking back and forth for how to potentially do that with like, the atomic data structures in C++, but I've never been particularly good at intuitively understanding multi-threading, so... I mean, I understand it, but I'm not particularly good at intuitively knowing how to use it. Look at that! Even over here it's, like, collapsing into the corner. That's so interesting. But yeah, if anyone has any ideas, I'd love to hear them. Also, I do have just something I'm curious to know. How many people that are new here picked up on the fact that the tall grass is billboarded? I did this a while ago, and I was unsure if I liked it or not, but I've been using it for a while now, and I really like how it looks, and it also halves the geometry cost for all of the grass. But like, I feel like it's almost impossible to tell unless you're really looking for it, and like, you see it rotating. But like, I'm actually a huge fan of it, because it keeps all of the pixels oriented towards you, which makes it less distorted. I still like the actual plants being like crosses, because they have more presence, but I think that the billboarded grass makes me very happy. You didn't notice? Hell yeah. What does the fluid direction function look like again? We scan each flow direction in this order, starting at a random offset within it. Oh, this shit's still here. Oops. We choose a random direction to start at, and then go clockwise around the flow directions. And then we sort based on its volume, so if it gets sorted so that the highest volumes are at the end, but in the case where it's flat, all the volumes should be equal. And then we start moving things into each position, attempting to go evenly, but in integer coordinates, which means that for a single volume of liquid, it's just going to move into the first possible direction that it found, and then do nothing else. I was thinking of having a flow map where I would move a mass of water, also I would store dirty blocks in a separate buffer and only update them. Oh wait, so you're talking about... Oh! So you're talking about having effectively a per thread, hold on, so you're talking about having chunks that are always accessible for multiple threads, and then having a per thread like cache of modified chunk data, and then you synchronize at the end of every frame step? I like that. My main concern is that like the chunk data is kind of large, and caching... Like, it's 32 by 32, and caching a 32,768 block region of data whenever a single block changes, no matter what, is kind of slow. It would be nice if there was a way to, like, intuitively know if something needs to be used on multiple threads at once. But that's what a mutex is, and that's slow, so... Maybe a bool to search clockwise might spread it out? I guess we could... that's gonna be annoying to program, though. Also, we already tried just reversing it always, and it didn't change the behavior. Ultimately, it doesn't particularly matter, because if we're at this low volume, I want to find a way to, like, either evaporate or, like, stabilize it anyways. No, you don't need to store all of them, only the blocks that will be modified in the current frame. But then I need to store, like, whenever I'm looking up a block, I need to also check if it's been dirtied in, like, some sort of unordered map, and I feel like that would also be quite slow. Like, I'd be worried about the performance implications of, like, having to do a logarithmic lookup for every single block as well. I guess I could use an octree, but that might be a lot of memory manipulation. It's a weird one for sure. I guess, like, if I did, I could try using run length encoding for, or even just, like, a linear list per chunk. So just, like, each chunk gets an array of dirty blocks, and then if it gets beyond a critical mass, then it just copies the entire chunk structure. Like, say, 100 blocks in one frame. I could see that working out. But I need to experiment more, but I do like that idea. Copy on write is probably the best way to do it, and then synchronizing it all at the end. I mean, realistically, synchronizing isn't even that important. Like, it's not like I have to manage merge conflicts, because only one chunk will have the authoritative, or only one thread will have the authoritative data, which will be whatever the world manipulation thread is. The rest of them just need to be able to have their old data so that they're not getting janked out when we're in the middle of updating stuff. But yeah, I think that's something that I'd like to pursue maybe next stream. I'm not sure where I'll go with that, or maybe I'll do more liquid stuff. I'm just trying to brainstorm, because I think I'm probably done writing, I think I'm gonna wrap up the stream pretty soon because I do want to go get lunch, basically. So yeah, next stream we'll probably either work on trying to do better multi-threading for the simulation stuff, and then we can also tie that into like animation and lighting propagation and stuff, and I think that'll improve the performance of the engine a lot. That task status graph that's constantly flashing over there is like the mesh re-renders, and each cell is a thread. So I already have the thread executor, I just don't use it for much. It only gets used for meshing and world gen right now, and I know it could be so much more powerful if I just utilize it properly. Dirty blocks can modify only neighbors. You can push new dirty blocks while iterating current. I'm not sure I completely understand. Basically, hold on, wait. Basically, if you have a block with delta volume equal to or close to 0, you don't need to update it. Oh, are you talking about the water propagation? Oh, yeah, sorry. Flow map where you move... I thought when you said also I would store dirty blocks in a separate buffer and only update them, that was talking about, like, the concurrency stuff. I feel like we've been speaking past each other for a little while. I already do only store liquids that can move in a dirty buffer. I don't I don't take every water in the world. It's just that these don't ever stop being dirty because they never settle. I do like having a flow map. That is something that I'd like to do, and I think it would make a lot of sense, and it would give us more emergent behavior. Like if we had water start here and flow this way, then even when it's like little water, it would all crash up against a wall, and then it would kind of keep sitting there for a little bit, suspend, and then fall back down. But like I agree, that would be pretty nice. I still need a way of stopping it. Right, you're talking about a block with a delta volume equal to or close to 0. I don't need to update it. So you're over time, huh. I already have a situation where I want to optimize flowing for stuff like rivers by analyzing the general flow into and out of a position over time, and if that is true, then it will continue like acting as though the flow is moving, but it won't actually update any of the liquid nodes within it. Basically just like on an octree level, like it's only doing the flow on like a larger scale. But trying to do it so that like the individual nodes don't update if their delta liquid isn't changing over time is interesting as well. Because that would allow it to try and settle for a while, and then it would eventually stop. I'd be worried about it settling slanted, but at that point I just need to have faith that the delta of the liquid would actually still be changing enough. Like, the only time it would settle uneven like that is if the leveling is really strange. Or like if the random chance gets really fucked up. Wait, but no, because random isn't even a factor here, because the way that the system used to work is it used to choose a random direction to move all the liquid. But now it doesn't do that. It chooses an even amount of destinations based on what it can move. The only time that it chooses a random spot is if it's trying to do it evenly, but it only has one volume. So the only case I'd have to be worried about is... Yeah, I think it's very limited. Like, there's very few cases where this could be a problem. No, I like that a lot. Optimize out updating liquids whose deltas, whose volume deltas don't change very much over time. And then also copy on write chunks with linear arrays of position and blocks. Also, compute liquids per chunk in separate, or per group in separate threads. Maybe. Also, don't remesh every block when a liquid changes. That's probably a good idea. Lazy heaps amortize to 0-1 inserts and merges the binomial tree. Underline the heap can just be an array, which is pretty easily shared amongst threads. Could be a good way to store the data you need. I don't really know about the details of your situation, though. Cool, I'll definitely take a look at that. My main thing is, like, well, the amortized cost might be very low. I need it to also be low in just, like, cycles as well. Not just, like, scaling. But yeah, I'm thinking, actually, for my purposes, a linear complexity, very quick thing might actually be better. Because it's hard clamped at, like if I'm storing per chunk, then the linear growth is hard capped at 32,768, and then I could probably do it differently. Like I could make it so that if you're storing more than 1,000 block changes on a local thread, it just copies the entire chunk data and then works like a normal chunk, because that's probably like the inflection point where it becomes useful to store them linearly. But I'm not sure. And I could also try to binary search the array as well, which, if I keep them ordered, means that, yeah, maybe a linked list instead of an array. I'm not sure. I just thought about rivers like blocks that have flow, but delta is 0, so it flows statically. Sorry, English is not my home language. No worries, yeah. No, that's basically what I'm planning as well, is I guess that would optimize that case automagically as well. Although the main issue is like actually maintaining flow into and out when the deltas change. I think I could actually combine this system with something I already had planned. The idea was going to be like for a 4x4x4 or something cell, if liquids are moving in and out at a constant rate, so like say that like 5 nodes are moving in, or 5 volumes moving in and 3 volumes moving out, and that's fairly constant over time, then it stops simulating the individual water, but it does keep adding nodes on like the borders of the next block, unless it's also frozen. So then like rivers only have to compute at the beginning and end. But I feel like your system could simplify that case into one case that also handles like leveled liquids like this, which is really cool. I think that would work out really well. I'll need to experiment with it more though. I'm a little bit too hungry to do it this stream though. But yeah, I think this is probably where I'm going to end the stream. We've been going for about just over 2 hours. I'm going to do my usual plug, but with a stipulation. I stream on every Sunday at 12 o'clock PST, noon PST. I have announcements on my Discord. Link is on the screen, bottom right, arrail.us/discord. We also talk about programming stuff there, and I post updates about the engine outside of stream when I have time to work on it. And it's just a cool place to be. I also make YouTube videos. I have 2 kind of high-effort videos that I made recently on this engine. The YouTube handle is also on stream if you're interested. But yeah, that's pretty much my main plugs. The stipulation is that I am going to visit my family for Christmas, and I probably won't have time to stream for a couple weeks. It's looking like I'll be gone for 3 weeks, and then I'll be back in the beginning of January. So just keep that in mind. I will be a little bit inactive if you will try to catch my streams in the future, but I will be back at the beginning of next year. It's Christmas time, and it's exciting. 11 p.m. here in Germany. Oh man, that's a large offset, wow. Oh, sort of like only doing the computations on the borders of the body of water. Cool, yeah, exactly. Like, because if river has constant flow, then we don't need to be resimulating each of those nodes, because over time they'd amortize the exact same position, even if they're kind of random. And then that means, like, if you have a really long river and a lake that's, like, emptying and a lake that's filling, you only need to compute the ends of it, right? And even then, like, there's already optimizations where, like, if the body of water is multiple layers, it won't compute liquid that's not adjacent to air, effectively. So only the top layer of the liquid simulation really matters. But yeah, I think that's gonna be it for today. Thank you for... Oh, I think I just fucking crashed it. Really? What happened? Whoop. Alright, I caused a seg fault. Looks like it was probably something to do with the fact that I'm breaking Vulkan constantly. I'm not thread safe in my Vulkan stuff. So that's probably something I could look into fixing in the future. But yeah, later here too, 2313, but tomorrow starts my holidays. That's nice. My holidays start on Thursday, so in like just a week, which is really exciting. But yeah, thank you all for hanging out. This was a lot of fun. I hope to catch you in the new year. Discord if you want to chat in the meantime. I don't know. I'll throw that link in chat as well. And other than that, have a great holidays. See you later, everyone. Bye.